Friends, so let's do this problem, okay? For the network shown, as same like before, find the transfer function I2 by V1, okay? So here the question is to find the value of I2 by V1. So where is I2? Here it is I2, and where is V1? V1 is as usual is the input voltage, okay? So here, basically here, the difference between this is here they have marked I2 in the question like over here. So this is not I2, this is simply I, okay? So this is the value of I2. So they are simply asking us to find the ratio of I2 by V1. Here you can, as usual, you can apply any method you want. You can apply mesh analysis or you can apply node analysis. But like I said, if you see any ladder circuit like this, okay, if you see any ladder circuit, it's always better you apply node analysis. Okay, this may not be completely ladder because of these two components, but then also it's okay. See, but these two items are actually parallel to each other. So all you need to do is simply combine them. That's all. That is, you see over here, let me draw the transformed circuit, right? What is the Laplace transform of resistor? It is 3 by 2. And for capacitor, it is 1 by Cs. And here the value of C is 2 by 3. So it is 1 by 2 by 3S. Or in other words, it is 3 by 2s, 3 by 2s. So therefore all you need to do is just combine these two elements together. These are parallel, right? So parallel means how do you combine them? By using the equation, this is 3 by 2 into 3 by 2s by 3 by 2 plus 3 by 2s. Or in other words, if you combine these two, what you will get? Let me see, you will get you get 9 by 4s at the numerator by, and at the denominator you will get this is 3s plus 3 by 2s, right? Into s, so you will become 3s plus 3. So 3s plus 3 by 2s. This s and this s will cancel each other. So you will have nothing but 9 by 6s plus 6. This is it, 9 by 6s plus 6. That is, after combining these two elements, you will get 9 by 6s plus 6. Or if you want, you can even simplify this. So you will get 3 by 2s plus 2. Okay, 3 by 2s plus 2. Now, okay, that's all I did is I simply combined these two elements. That's all. Here the impedance is 3 by 2. Here the impedance is 3 by 2s. So I just combine these two into a single element. So now I'll get a perfect ladder circuit. Okay, so if you get a perfect ladder circuit, it is always better you apply node analysis, because node analysis will save you a lot of time. Then the problem becomes very simple for you. So let's join this. So I'm going to combine these two elements. I will get an impedance, and this impedance is this one, 3 by 2s plus 2. Okay, very easy. 3 by 2s plus 2, and then you have a resistor over here, right? If you want, you can combine these two elements into a single element. That also will save you a lot of time. Let me do that also. So that will save you even more time, right? If I combine these two elements, that is this element, these two elements combination plus this resistor. So what will I get? I will get 3 by 2s plus 2 plus 1, which is 3 plus 2s plus 2 by 2s plus 2, which is 2s plus 5, right? 2s plus 5 by 2s plus 2. Okay, so now I can combine these two elements. So I combine this whole thing into a single element. So there, now again I am simplifying it, this problem even more further. So what will I get? I will get a total impedance, okay, and this impedance is this one, 2s plus 5 by 2s plus 2. See, very easy. And the rest of them is the same. This is a capacitor, and the capacitor is 2f, right? 2f, 1 by cs. So here this value of c is 2. So you'll get 1 by 2s. And this is a resistor, and there's no change. It is 1 ohm itself. And you have another resistor, that also no change, which is 1 by 6 itself. Okay, that's it. Right? I think I made a mistake over here. I think this capacitor should come on the other side, right? This capacitor should come on the other side. So this is the problem. This is how it goes. This is a capacitor, not this diagram. This capacitor should come on the other side of the resistor. So you have this impedance. You have this this capacitor over here. Then you have a capacitor over here, and after this capacitor you have this resistor right here. This is 1 by 6. 1 by 6. This is 1 by 2s. 1 by 2s. That's it. All right. This is plus minus. This is V2. This is I equal to 0. This is what you call as I2. And this is plus minus. This is called as V1. And this is I1. See? From a circuit that is looking like this, I now simplified it into this. Okay. And the value of this impedance is 2s plus 5 by 2s plus 2. 2s plus 5 by 2s plus 2. See, so now it's easy for you to say, right? It's very easy to see. You can say this is nothing but you can use Kirchhoff's current law. That will be more simple. See, because if you look very carefully over here, this is V2. See, there is no element over here. So if this is V2, then this is also V2. Okay. Since there is no element over here, if this is V2, then this is also V2. So this entire connection, this entire wire that you see here is actually a single connection because there is no resistor or capacitor or anything in between. See, so this is entire single connection. So this entire line is actually V2. Okay. So therefore, this is V2. I can mark this as V2, this is V2, this is also V2, and this is V1. Okay, and the question was what to find I2 by V1. Okay, so we will find I2 by V1. Okay, first what I'm going to do is I'm going to apply my Kirchhoff's current law over here. Applying Kirchhoff's current law over here, I can see here I is equal to 0. So therefore, if I'm applying Kirchhoff's current law over here, I will get minus I2 plus V2 minus 0 by 1 by 6 equal to 0. Right? Applying Kirchhoff's current law over here, this is the equation I get. This can be also be written as minus I2 plus 6 V2 equal to 0. That's it. I got a beautiful equation. That is, this means that this is this one minus I2 is plus I2 because this current is outgoing current, right? So it is plus I2. Okay. So current is outgoing, all outgoing. If I'm considering this node right here, so it's an outgoing current. So all outgoing current should be considered positive, and incoming current must be considered negative. So this is outgoing, so it will be positive. That's why. So I will get I2 is equal to minus 6 V2. This is the equation I get. First equation I got. Okay. So I2 is here. The question is to find I2 by V1. I found an equation for I2. Now next I'm going to write the equation for this node. This node V2 over here. Okay, both of them have the same name. So here in the node is V2. So what is the equation of this node over here? Here you can see that this current is incoming, right? I2 is incoming. So it is minus I2 plus the current over here is V2 minus 0 by 1 by 2s plus, and what's the current over here? V2 minus V1 by this impedance, which is 2s plus 5 by 2s plus 2 equal to 0. This is the equation. So here, if you here we are trying to find I2 by V1. So simply find I2 by V1 and substitute the value of V2. So which means you don't want V2. So what I'll do, I'll substitute the value of V2 and I'll substitute the value of V2 as minus I2 by 6, right? I can substitute V2 as minus I2 by 6. That's it. Because very easy. So you'll get over here as minus I2, okay, plus 2s V2 plus, and here you get 2s plus 2 by 2s plus 5 V2 equal to, I'll put this V1 over here, so I will get 2s plus 2 by 2s plus 5, 2s plus 2 by 2s plus 5 V1. Okay, this is what I will do. And what else I can do over here? That's it, no? So now what I'm going to do is, I think I will convert all this V2 in terms of I2. So I will get minus I2 plus, here this will become 2s V2 and this is I2 by 6, right? So you will get 2s into minus I2 by 6 plus, and this is also 2s plus 2 by 2s plus 5, and this V2 can be written as again minus I2 by 6 is equal to 2s plus 2 by 2s plus 5 into V1. So you'll get over here as what am I going to do? I think I have to divide this whole thing with I had to divide this whole thing with 2s plus 5, right? This whole thing should be divided with 2s plus 5. Is there any shortcut method? Oh, I hate it. I hate when there's no shortcut method. So I think we have no choice but to do this in the usual style, that is taking in terms of 2s plus 5 itself. I don't see any other method. Okay, so let's mark this. So you'll get over here as minus I2 into, this is the LCM, right? Taking the LCM, you'll get 12s plus 30. 12s plus 30, that's what you're going to divide over here. Plus, and over here already there is 6, which means you need minus 2s I2 into, you need the remaining part, that is 2s plus 5. Okay, and here it is as usual. You will get plus, and here it is 2s plus 2 minus I2 divided by 2s plus 5 into 6. This is one side of the equation. The other side of the equation is laughing at me. 2s plus 2 by 2s plus 5 into V1. So this 2s plus 5 and this 2s plus 5 will cancel each other. That makes me so happy. Then you have here as minus 12s I2 minus 30 I2 minus 4s square minus 4s square I2, oh my god, minus 10s I2 plus, not plus, it's minus 2s I2 minus 2 I2 by 6 into 2s plus 2. Okay, what an ugly looking equation. So here you get what you can do over here is you can combine all this s terms together. So you'll get here you have minus 12s, so here you have minus 10s, here you have minus 2s. So 12 plus 10 is 20, 20 plus 2 is 22. So you have minus 22s. So you have minus 4s square I2 minus 22s minus 22s I2, and what about this is minus 32 I2, minus 32 I2. Okay, minus 12, let me see if I have missed anything, minus 10 and minus 2. So you get minus 22, sorry, this is minus 22 minus this minus 24 actually. Okay, minus 24 is I2. I knew I'd make a mistake. So this is the equation. Divide by 6 into 2s plus 2 is equal to V1. So I'll take I2 common. I don't know why I'm taking I2 common. So if I take I2 common, I will get I2 into, here you'll have minus, I'll take minus I2 common. I don't like this minus over here. So you'll get what? I'll take 4 also common. There. That makes it more simpler. So you'll get what? S square plus, and here you'll get s square plus 6s plus 8 by, and what about over here? Here you have so you'll have 6 into 2 into s plus 1. There you go. So let me see what magic I can do over here to make this thing more interesting. Here you get 2, and this 4 will become 2, and this 2 will cancel, and this 6 will become 3. So you'll get the answer as minus I2 into What terms can you bring over here? S square plus 6s plus 8. If you want to factorize it, find two numbers in which if you add them you will get 6. If you multiply them you will get 8, and that is 4 and 2. So it will become s plus 4 and s plus 2 by 3 into s plus 1 is equal to v1. So from here I can say, oh, the question was to find I2 by v1. So I2 by v1 is equal to minus 3 into s plus 1 by s plus 4 by s plus 2. There you go. So this is how we do the problem. So you see these kinds of questions, okay, you can do it, you can apply any method you want. Only thing is that now don't make mistake when you're trying to apply the Laplace transform to the resistor, to the capacitor, or to the inductor, or wherever it is. That's all. You can apply Kirchhoff's voltage law or Kirchhoff's current law, but I prefer Kirchhoff's current law for these kinds of equations because the circuit is in the ladder shape. So you can apply node analysis. That will save you a lot of time. Okay. Then the rest of them depends on your speed. Okay. So as of now, it took me around 16 minutes to do this problem if I'm looking at my time right. So this is it. Okay.